This is lesson 3 in chapter 2, solving multi-step equations, this time with a variable on both sides. Now, we've so far spent 2 days on multi-step equations, and on Tuesday we kind of had an introduction and we looked at some multi-step equations that include distribution and combining like terms. But in all of these cases, we've had the variable isolated on one side of the equation, so on one side of our equal sign. This time, I'm going to throw some new ones at you that have a variable on both sides. So, since these equations now have a variable on both sides, it is even more important to follow the steps very carefully. Now, if you are still confused about what the steps are, you can go back in your notes from our second lesson, and I have them right here for you, okay? So you really need to be using those steps. And I will go over them again in the video as I'm doing examples, okay? So as far as notes or any kind of fill in the blank or vocabulary goes, there is none. The only way you get better with multi-step equations, well, in fact, the only way you get better with any kind of math is to practice, but especially when it comes to multi-step equations, and that's why we're spending 4 days total on this. So the rest of this week we'll be working on these, and then Monday we'll have kind of a review day, and Tuesday will be your first quiz in chapter 2. All right, so let's get started. Now, let's look at 31. Let's just start right away. Solve each equation. So my first step, before I even start looking at what the equation is, I told you guys you need to draw a line down your equal sign. Split your equation up into 2 sides. And like I told you, this time we're looking at equations that have our variable here on the left side and it's on the right side. So we have it in 2 separate places. And we need to somehow get all of the terms that have the variable onto one side together and then all the constants back to the other side. So our first step was to draw a line down the equal sign. We did. Second step is look for any distribution. Is there any distribution here? I don't see any parentheses, so I'm going to say no. There's no distribution. Second step, combining like terms. Well, let's look at each side of the equation separately. On the left side, are these 2 terms like? Can I combine them? That answer is no. So I just leave this the way it is. 3x minus 8 equals. On the right side, I have 3 terms, and 2 of them have an x. So those are like terms, and I need to combine them. So here I have 1x plus 2x is 3x, and then my constant minus 8. Okay, so now I just need to go ahead and solve. So I've got negative 3x. I'm going to move my x's to the left side, okay? So I'm going to subtract 3x from this side, and oh, hey, look what happens when I subtract it from the left side. It cancels here, 3x minus 3x, so 3 tables and take away 3 tables, you have no tables left. They cancel, they're gone, right? And the same thing happens here, right? 3x, 3x, they're gone. So all I have left is negative 8 equals negative 8. Well, is that a true statement? Does negative 8 equal negative 8? It sure does. Nothing else equals negative 8 but itself. So what this means, when you end up canceling out both of your variables, what this means is there are infinitely many solutions. And what that means is we could pick any number to be x, any number at all, and what would happen is these 2 sides will balance out. All right, so if I picked 10,000 and I wanted to make x be 10,000 and I substitute 10,000 everywhere I see x, no matter what, these 2 sides will always be equal to each other. Infinitely many solutions. This sideways 8 is the symbol for infinite. All right, so that was kind of a tough problem to start off on. So let's look at another one. Let's go over here on this side. All right, 32. Let's draw a line right down our equal sign. And we're going to combine like terms. So we have 4 plus 3 on this side is going to be 7. And then minus 7v, there is no other like term, so minus 7v equals, on the right side, these two are not like terms. This has a variable and this one's a constant, so just rewrite it, -9 minus 3v. And from here, you're gonna solve. Just pick a side that you want your variable to go on and move everything over. So if I move this -3v over to the left, what's gonna happen is 7 plus 3 is gonna give me a negative variable. And I mean, that's fine, but it's kind of nicer if you try to get a positive variable. It doesn't really, like I said, matter either way though. I just like not dealing with negatives, and I think you guys would all feel the same way. So I'm gonna move all my variables to the right. I'm gonna say plus 7v plus 7v. And then I have this 7. That's the only thing that's left over because -7v plus 7v is gone. So 7 equals -9. What's -3 plus 7? Positive 4v. All right, still not done. I have my variable isolated to one side, but I need to move this constant over here to the left with the other constant. So plus 9. And this is going to be 16 equals 4v. And then my last step, let's use that inverse operation to get v by itself. This right now is multiplication, so I need to divide out that 4. And v equals 4. Oops. So for this one, because we actually get an answer for our variable, there's only one answer that v can be, and that is 4. As compared to 31, because our variable ended up canceling out and -8 will always equal -8, that means that there are many solutions. Your variable x could be any number in the world, but in this problem, it can only be 4. Only the number 4 will make these two sides balanced or equal, okay? Because that's the whole point. They're equal. That's what this equal sign means, okay? They have to stay the same. I want you to try the next 4, 33, 34, 35, and 36. Give them a try. And let's go flip over to the back and look at maybe one or two that has some distribution. I'm going to do 41. Let's do a real messy one. I left you lots of room to do this also. Okay, so first step, draw a line down our equal sign, which we did. Second step, we need to distribute. Look for any distribution. And look, I have it here on the left side and here on the right side. So let's take care of that first. Remember, this -3x, this term out in front, has nothing to do with the distribution, so we'll just rewrite that and leave it alone. So -3x, -7 times 4 is -28, and then -7 times 3x is 21, so positive 21x equals, now let's distribute on the right side. 3 times 8 is going to be 24x. Keep that a variable. 3 times 4 is going to be 12. And then this minus 2x, rewrite that, had nothing to do with distribution. Second step, combine like terms. And oh yeah, I'm definitely going to need to combine some like terms on the left side and the right side. So we've got -3 plus 21, so that's going to be 18x minus 28 equals, and then on the right side, 24 minus 2. Both have an x, so 24 minus 2 is 22x plus 12. All right, once again, looking at these, I have no more like terms to combine. I just need to figure out what side I want all my variables on and what side I want all my constants on. Now, if I were to subtract 22 and move all my variables to the left side, what's gonna happen is I'm gonna get 18 minus 22, and that's gonna give me a negative value. Like I said, you can do it that way. I just personally don't like to deal with negatives, so I try to avoid them. So what I'm gonna do is I'm gonna move the 18x, I'm going to move all my x's to the right side, because if I subtract 18 from 22, I'm going to get a positive answer. So let's do it that way. 18x. Man. All right, on this side, they're gone. We have -28 left over. Now 22 minus 18 is going to be 4x. Look, it's a positive. Yay. And then, I'm sorry, we just have positive 12 left over. Okay, just rewrite this below. Now I need to take one more step and move my constants over here. So subtract 12. Oh, hey, look, I'm going to have to deal with negatives anyway. So that really didn't help me much. So I need to move all my constants over here to the left. Negative 28 minus 12 is going to give me a negative 40. Equals what's left on the right side, only the 4x. Now I just need to use my inverse operation, divide out that 4, and negative 40 divided by 4 gives me negative 10. All right. Now I know this video is getting pretty lengthy, but I think that it would be beneficial for you especially to see me do one more. So if you think you've got a good grip on things now, you can go ahead and stop the video and do the rest of the examples on your own. So I'm going to leave the rest of this video as optional if you just need to see a couple more examples, okay? So let's go down to 43. 42 looks a little menacing, but I think if you look at my example from 41 that you could handle it. So I do want you to try 42 on your own. I'm not going to do all of the difficult ones for you. You got to try some of them on your own. Okay, even if you get it wrong, the only way we get better at anything is to make some mistakes and learn from them and improve. Oh my God.
Forgot to say there is no INN today. Thank you.
So the only way for you to get better is to try something, make some mistakes, and then learn from your mistakes. That way you can improve next time, correct? So let's get started. First step I did, separate my equation into two sides, line down the equal sign. Then I'm going to do any distribution, and here I do see distribution here, and then on the right side right here. So let's distribute. Remember, your k on the outside is not part of this distribution. He's kind of over here on the side. He's got nothing to do with it. So let's rewrite the k. And then we have 2 times 8k is going to be plus 16k. And then 2 times negative 7 is minus 14. Equals. Then on the right side, let's distribute again. 7 times 1 is 7, and 7 times 2k, that'll be positive 14k. All right, combine like terms. On the right side, I don't have like terms. This is a variable, this is a constant, so nothing there. However, on the left side, I have 2 terms that have a k, so let's combine those. 1k and 16k is going to be 17k minus 14 equals 7 plus 14k. So this time I'm gonna move my variables to the right side because 17 minus 14 will give me a positive. I just like to avoid the negatives at all costs. So negative 14k, let's subtract it. Okay, on the right side, all gone. On the left, 17 minus 14 is gonna be 3k minus 14, just rewrite this term up here, equals 7. Let's move this constant over to the right side by adding it. Okay. And then this is 21. 3k on the left. Last step, almost done. Divide out that 3, and k is going to be equal to 7. Now I know I've left you with a lot of examples to do on your own, but I really want you to give them a shot. And actually, when we come to class tomorrow, we're gonna spend quite a lot of time working on these. So take your time, really look at them, and we'll go over them in class, okay? And please don't forget to answer your WISC questions on Schoology, and make sure that you have these examples done in class tomorrow because, like I told you, your homework grade is going to be split up into 2 parts. Part of your grade for answering the questions and part of your grade for doing the examples and taking notes. So make sure you get those things done.